Hello. Today I will be presenting the final project for IDS 706 Data Engineering Systems, which I worked on alongside Liu. So in this project, we were tasked with building a microservice that interfaces with a data pipeline. And in this presentation, I'll be going over a basic overview of our project, some of the specifics related to our file contents, as well as showing the app itself, and then some of the load test performances. So starting with our overall architecture here, we develop our microservice using FastAPI, where the main benefits of using FastAPI are that it's easy to use and has particularly high performance. But also another benefit with the FastAPI application is that it has containerization with distroless. And by using distroless containers, the FastAPI application is not only very efficiently packed with its required environments, but we also gain a certain enhanced level of security as well. Finally, we have cloud infrastructure with infrastructure as code, specifically within Microsoft Azure Functions, where we enable the application to scale dynamically based on demand, ensuring cost-effective resource utilization. The integration of infrastructure as code with Azure Functions also enhances service reliability and performance, allowing for seamless scaling and management of resources in response to varying loads. And we'll see later on with some load testing, some of the validation related to that. But moving on to some of our project structure, we leverage GitHub Actions for continuous integration and delivery, which allows us to ensure code quality and have some seamless deployment as well. In terms of data interaction, we follow a simple ETL process within our mylib folder of our repo, and I'll be going over this in more detail later on. And then finally, with the front end, we have a single home.html file, which offers our clean interface that allows the user to interact with our service. Specifically, in this case, we created a grocery inventory app, and the interface allows our user to find groceries based on certain keywords, or also find groceries based on certain counts within the inventory. So to go into this in more detail, we can go to our mylib. I'll just go over a quick rundown of these three files. We start with extract.py, where we're simply extracting a data set from a URL. So we already have our URL here. It's a grocery data set containing information on grocery inventories, as well as information and keywords related to the groceries themselves. So we extract this URL to a file path within our repo. And then from that file path, we can then use transform load, which loads the data into a local SQLite3 database. We also perform some necessary transformations here as needed, just to create the overall schema of our data that we want. And then moving on to query.py, this is where we can actually create our table with our keys, as well as the data types. And then we can do some queries that we would like to implement into our application. Specifically, our first query, we're simply querying based on a keyword. So we're selecting all of our columns of interest from the grocery database, where the general name is similar to a certain keyword that the user will input. And we're also, from these queries, we're returning the results in JSON format. That is very important for the execution of our application. And our query 2 here, as mentioned before, we're again just selecting the names of our groceries from our database where the count products are greater than a certain threshold. So if we're interested in groceries with more than a certain count that are available in inventory. And once again, we're returning in JSON format. So that's our mylib folder within our repo. We can also look at our templates. So we just have a single HTML file here, which basically creates the user interface for our app, including titles, the text input box, as well as the buttons that we need for the user interface. So that's quite simple. So moving on to the app itself, we have this link here. This is our grocery inventory app. It's very easy to use. The user can simply enter a keyword and filter groceries based on that keyword. Same thing with counts. You enter an integer amount, and then you'll be able to see information on groceries based on having inventory greater than that count. And our data queries are processed by Fast API, which allows us to communicate with the grocery DB database to fetch and update our data. And then the whole process of allowing this app to be displayed is that we build and push the Docker image through Docker Desktop and Docker Hub, and we deploy it to Azure Web Services. So we have an actual product in Azure Web Services that allows us to deploy the app. And then finally, we can look at some of our performance features. We've optimized our microservice for high traffic. The service can support up to 10,000 requests per second, providing uninterrupted access to grocery information. And so we perform our comprehensive load testing using the Locust module in Python, and we set it to test at 10,000 requests per second. So these are the results of our load test. And then we can also get some information regarding CPU usage and memory usage percentage as displayed here. And yeah, that's basically the presentation. Thank you for listening.